Section 8.2 deals with L'Hopital's rule, which helps us to find a limit when we have an indeterminate form. Sometimes when you look at the limit of something, you get some different answers that we don't really know how to handle. 0 over 0, infinity over infinity. Sometimes you get infinity times 0 or infinity minus infinity. All of these guys are what's called an indeterminate form, which means we don't know much from what we've been given. So we have to do a little bit more math. There's a mathematician, his name was L'Hopital, and he came up with this really cool formula that works. It's really neat, and it allows us to find the limit of these different things when we get one of these indeterminate forms. So what we're going to look at is the first form, which talks about being 0 over 0. And you know, you can't divide by 0, okay? 1 divided by 0, we know that that's undefined. We are not changing what we think about that. But if we have 0 divided by 0, that's something else. This is indeterminate. Okay, so notice that there's a difference here. So as long as I can take the derivative of both functions, and as long as g doesn't equal 0 when I take its derivative, we can use what's called L'Hopital's rule. So here we go. Estimate the limit graphically and use L'Hopital's rule to find the limit. So according to our rule up here, we need to take the derivative of the top. So I'm just going to rewrite the top. I'm going to call it f of x. So that's going to be 1 plus x to the 1/2 minus 1. The derivative of that is 1/2 times 1 plus x to the negative 1/2. The derivative of 1 is 0. And I'm just going to clean this up just a little bit by saying that f prime of x is equal to 1 over 2 square roots of x, 1 plus x. Okay. G of x then would be the denominator. So if g of x equals x, then g prime of x equals 1. So basically the denominator becomes 1, and we're left with just sorting through with this guy, because it would be this guy over 1 according to L'Hopital's rule. So instead of having the limit as x approaches 0 of all of this, I would have the limit as x approaches 0 of 1 over 2 times the square root of 1 plus x. So if I look at the graph of square root of 1 plus x minus 1 over x, it looks like at 0, which is where my limit is told, given to me to check, it looks like it's going to be a half. And if you'll notice, there is a limit there, because we approach 0 from the left, and as we approach 0 from the right, the y value, which is where that limit occurs, this y value in here is really what we're interested in. And it looks like it's going to be a half. Well, all we need to do now is take the 0 and put it into our new equation that we got from using L'Hopital's rule. So I'll just come on the other side of that graph, and we're going to look at x approaches 0 of 1 over 2 times the square root of 1 plus x, which is going to be 1 over...
Is it on?
Yes. 2 times 1 plus 0, which would be a half. And that is what we discovered by looking at the graph. So using L'Hopital's rule and looking at a graph, we can see that this limit's going to be 1/2.